everyone, I am Manuelin back and again with another math tutorial video. So my topic for today is about scientific notation. Scientific notation, also called standard form in Britain. So what is scientific notation? A shorthand method of writing very small and very large numbers is called scientific notation, in which we express numbers in terms of exponents of 10. To write a number in scientific notation, move the decimal point to the right of the first digit and the number. Write the digits as a decimal number between 1 and 10. So what are the 4 rules in scientific notation? Rule number 1, the base is always 10. Rule number 2, the absolute value of the coefficient is greater than or equal to 1 but less than 10. Rule number 3, the coefficient carries the sign positive or negative. And lastly, rule number 4, the mantissa carries the rest of the significant digits. The number is written in 2 parts. Just the digits with a decimal point placed after the first digit, followed by extend to a power that puts the decimal point where it should be. It shows how many places to move the decimal point. So we have here an example. So 5,326.6 in scientific notation is 5.3266 times 10 to the power of 3. So the digits here is 5.3266 and the power of 10 is the 10 to the power of 3. In this example, 5,326.6 is written as 5.3266 times 10 to the power of 3 because 5,326.6 is equal to 5.3266 times 1,000 is equal to 5.3266 times 10 to the power of 3. Example: why is 700 written as 7 times 10 to the power of 2 in scientific notation? 700 is equal to 7 times 100. And 100 is equal to 10 to the power of 2. So 700 is equal to 7 times 10 to the power of 2. Both 700 and 7 times 10 to the power of 2 have the same value, just shown in different ways. Another example is we have 4,900,000,000. 1 billion is equal to 10 to the power of 9. So 4,900,000,000 in scientific notation is equal to 4.9 times 10 to the power of 9. Another example. So we have now 6.022 times 10 to the power of 23. So 6.022 is our coefficient and the base is 10, while the 23 is our exponent. When you move the decimal to the left, the integer will become positive. When you move the decimal to the right, the integer will become negative. So our example in positive integer is we have 4,500 is equal to 4.5 times 10 to the power of 3 because we move the decimal point to the left. 0.0677 is equal to 6.77 times 10 to the negative 2 power because we move the decimal point to the right. So how do we write numbers in scientific notation? 284.6 is equal to 2.846 times 10 to the power of 2. 0.0245 is equal to 2.45 times 10 to the power of negative 2. 3,125,000 is equal to 3.125 times 10 to the power of 6. Negative 0.0042 is equal to negative 4.2 times 10 to the power of negative 3. 0.00056 is equal to 5.6 times 10 to the power of negative 4. 245,000 is equal to 2.45 times 10 to the power of 5. 240.06 is equal to 2.4006 times 10 to the power of 2. So, like what I've said before, if you move the decimal places to the left, so the integer will be positive, and will you move to the right, the integer will be negative. So why is it important to study scientific notation? Scientific notation is useful because it allows us to easily write and make calculations with extremely small and extremely large numbers.